Okay, in this video we're going to solve quadratic equations by something called completing the square. So let's go back to some basics here. If I have something like x squared is equal to 81, I know that I could take the square root of both sides, and I know that the square root of 81 is 9. So I get x is equal to 9. It's actually not just 9, though, because there's one other answer, and that's negative 9, because negative 9 times negative 9 is 81. So it's equal to plus or minus 9. I can have a more complicated expression like, let me actually erase that. Don't want that yet. I can have a more complicated expression like, let's say, x plus 2 squared is equal to 25. I can take the square root of both sides. And I can say, oh, that's cool. That's x plus 2 is equal to plus or minus 5. And so that's x plus 2 is equal to 5. Subtract 2 from both sides. I get x is equal to 3. Or that's also equal to x plus 2 is equal to a negative 5. Subtract 2 from both sides. And I get x is equal to negative 7. So my answer I usually write as x is equal to 3 or negative 7. I should have actually written the negative 7 first. Okay, so our goal is now to get things that are in a form of ax squared plus bx plus c is equal to 0 and fit them into this type of thing. Later we'll do that in a generic way and develop something called the quadratic formula. Right now, we're just going to do it with a particular sample. So, for example, let's say I have, I think I'll change colors here. Let's say I have x minus 6x plus 8 is equal to 0. And I could factor that and solve it that way, but I'm not going to. What I want this to do is I want to get this in the form of something like, remember when we had a minus b squared, and that was a squared plus 2ab plus b squared? Well, I want to get it in something like that, because then when I took the square root of it, it would just simply be a minus b. So I'm going to make it look like something like that. I'm going to get it back. I'm going to get this into this form, so I have a middle term like that's like this 2ab here. Okay? And so this is how I'm going to do that. I'm going to say, I'm going to go x minus, oh, this is x squared, by the way. So I'm going to have x squared minus 6x plus 8. Well, first of all, actually, before doing that even, to start to get it to that side, I'm going to subtract the 8 from both sides. I'm going to get this to be negative 8 over here because I subtracted 8 from both sides. I'm going to add something over here to make this so that it's an a minus b squared type of thing, that I could factor that into something minus something squared. And the trick is, what do I pick here? What do I pick here? And if I'm adding it to that side, I'm going to have to put it over here too. Well, what I want this middle part to look like is I want this to be, you know how I had like 2ab over here? Well, I want it to look sort of like that, 2ab. So what I'm going to do is I'm going to do this. I'm going to take negative 6. I'm going to divide it by 2. And then I'm going to square it. Okay? So negative 6 divided by 2 is negative 3 squared, and that's equal to 9. So to get this, like this 2a thing, to get this to be like the a, I need to divide it by 2, and then for this term, it's going to be this b squared. So that's the b I'm trying to get here. So I'm going to square this so it's 9, and hopefully that's making sense. But the mechanics of it are, you're going to take this, you're going to divide it by 2, and then you're going to square it. Once you do that, this becomes x. It's this divided by 2 thing here. So it's going to be x minus 3 squared. Because if you look at this, this is x minus 3 squared. This is like this is like this up here. And so this is x minus 3 squared now. So I've made this into something by picking this here. I've made this into something that I can factor this way with our special factoring special polynomials here. I have x minus 3 squared. And then all of that is equal to whatever negative 8 plus 9 is, and that's simply equal to 1. Okay, now this is a lot easier looking. Now I've developed this so I can take the square root of this side, and I can take the square root of this side. Square root of this side is simply x minus 3. And the square root of 1 is equal to plus or minus 1. Now, I'm going to go here, I'm going to draw a line here and then do this here. So I got x minus 3 is equal to, let's do the plus 1 first. Add 3 to both sides. And I get x is equal to 4. And then I have x minus 3. Trust me, I accidentally dragged the pen across there. Is equal to negative 1. I add 3 to both sides. And I get x is equal to 2. And so my final answer is x is equal to 2 comma 4 here. Okay. And so that's the basics of it. I'm going to try a more complicated one, though, because one thing I need to emphasize is that this initial term here needs to be 1, or this coefficient here on the x squared term needs to be 1, and if it isn't, you need to make it 1. So I'm going to go through one that is like that. And so let me close this down. So I'll get a new one and I won't save it. And so we're going to do this one here. We're going to do 2x squared plus 14x plus 24 is equal to 0. Now, this term here, this coefficient to the 2x squared term, isn't 1. I need to make it 1. You would want to factor that out anyway, even if you're factoring here, because you can factor it out. But even if it results in fractions over on this or this, you have to do it. This one isn't too bad here, but you got to make sure. So what I'm going to do is I'm going to multiply both sides by 1/2. And so, and multiply this by 1/2. 1/2 times 2x squared is x squared. 1/2 times 14x is 7x. And 1/2 times 24 is 12. And that's 0 times 1/2 is simply 0. Now, we want to get this into, this is going to be a plus. We want to get into x plus something squared. That's the way we want it. So we need to make this as x squared plus 7x. First thing I'm going to do is subtract 12 from both sides. So we get a negative 12 here. But then we need to add something here that will make this as x plus something squared. And if I add it to that side, I have to add it to this side. So, I'm sorry, I didn't mean to make that 72. I wanted to make this, this is 7x. Okay, so what we're going to do this is we're going to take this, because we want it like that 2ab, okay? So we're going to take 7, we're going to divide it by 2, and then we're going to square it, and that gives us 49 fourths. So what we have to add on both sides here is 49, I think I'll just use this bar as the fraction bar, fourths to both sides. Okay, because we took half of the 7 here. So it's going to be like 2 times 7/2 is 7 times x. That's what we want. And then we have to add it over here. Okay, so I've done that. And so now what this here means, is that this must be x plus 7/2, the square root of this, squared. And if you were to multiply that out, that would give you back this, okay? And then all of that over here is equal to whatever this is. I'm going to be simplifying this a little bit. Let's just simplify this side a little bit. Negative 12 we're going to make into fourths, so that's a negative 48 fourths. Multiplying top and bottom by 4. Plus 49 fourths. Well, that's good. That's coming out a lot more manageable. So all of this is equal to 1/4 down here. Okay, so back to here. I'm going to take the square root of both sides. And so what I get is x plus 7/2 is equal to plus or minus the square root of 1/4. The square root of 1/4, it would be 1/2, so plus or minus 1/2. And so I'm going to go up here now and finish this. I'm going to go x plus 7/2 is equal to, let's take the positive one first, positive 1/2. I'm going to subtract 7/2 on both sides. And I'm going to get x is equal to negative 6/2, or x is equal to negative 3. So that's one of my solutions. The other one is going to be x plus 7/2 is equal to negative 1/2. I'm going to subtract 7/2 from both sides. And I'm going to get x is equal to negative 8/2, or x is equal to negative 4. And my final answer is going to be x is equal to negative 4 or negative 3. I'll box that in. So hopefully you followed that. That's pretty difficult stuff, but you can do it. And with that, I will close this video.